Hi, I'm Chris. Today I'm going to be teaching you guys about electronic troubleshooting. Here at RSI we have built several of these boards to take you through the steps of troubleshooting these units mechanically, or electronically, sorry. Mechanically we'll get into later. One of the tools you guys are going to get in your tool bag is this multimeter right here. The one you guys will get is a field piece. This one I brought from home, it's mine. But you always want to start with turning that thing on because you're not going to read anything if the thing's not turned on. Okay, so I'm going to kind of take you through the steps on how to troubleshoot these units with your meter and doing the electronics. So typically you're going to start by turning the unit on. Okay, so the power's on and you can kind of see now my motors are all functioning, so there's no problems initiated. So what we're going to do, the students actually take the switch, they flip the switch and something will happen. They'll kind of visually see what's going on with the unit, what's not on. And what I teach them is I look at what's not on and I try to teach them like who tells that what to do. Okay, so I have a blower fan. This would be the fan that would be blowing the air into your house. Okay, that's not on. I also have another fan that'd be your outdoor fan or the condenser fan. And there's also the compressor. These two components are usually outside of your house and there is what's going to make your air cold. Okay, they're moving the refrigerant around and then this one's blowing that cold air into my house. So right now I have nothing going on in the house. So the first step I would do is I would take my meter leads and like I said, I should have my meter on, otherwise I'm not going to read anything and it's kind of pointless to try to do that. So I look at my blower motor right here is controlled by this relay. These two motors right here are controlled by this relay. This is a contactor, this is an all-purpose relay. Since they're both not on, I can tell in the field that normally these relays will not fail at the same time. Something else is going on. So I'm going to look at who tells these two relays what to do. Typically in the field, that's going to be the thermostat inside your house, the thing you will turn the temperature up or down to make the unit come on or off. So I want to start there, but I'm already either up on the roof or I'm in an attic. So I'm not going to waste my time climbing back down. So I'm going to go to where the power comes into the unit and starts here. So what I'm going to do is I'm going to take one of my meter leads and I'm going to put it on the common of the transformer, okay? And then I'm going to take my other meter lead and I'm going to put it on the red terminal right here, okay? If I do that, I should have some voltage coming in. If everything before that, the transformer and my disconnect is good, I should have power here. So I'm going to look, and I do. And what that tells me is that my transformer right here, that's the thing that takes our high voltage coming into the unit at our disconnect and converts it down to a lower voltage for our control system. So that tells me right there that I have power going to the house. So now I want to see if is it coming back out of the house. So I'm going to go back to that common spot that I was at before. And now I'm going to check the yellow circuit because the yellow circuit is what actually takes care of this contactor down here, which turns on these two. And I'm looking for voltage again. That means the thermostat is sending it back out. This particular one, I don't have power on that. But I also want to check the green circuit because the green circuit is what turns my blower on here. So I'm going to go to the green wire and the common wire. And again, I'm looking for voltage. I look at it, I don't have anything. So what that tells me is I have power going into the house to the thermostat, but the thermostat is not actually sending it back up to the unit to turn it on. So in this particular case, it would be considered a bad thermostat. So in the field, I would replace this. Okay? Once the students are done and they've figured out that problem, they flip it back to normal. They move on to step 2. And again, we're looking for what's not on, what's not working. Okay, so on this particular problem, my blower fan is actually working, so I'm getting air into the house. The problem is, though, is that my outdoor fan and my compressor are not. And those are what's going to move that refrigerant around and actually make the refrigerant cold so I can get cold air in the house. So at this moment, we have hot air blowing in the house. That's not good. That's why you get a call and you're going to show up. So I'm going to look at, because of this thing being on, I'm not worried about anything up here. My high voltage, my transformer, not even my thermostat, because this is on, that tells me my thermostat's getting power and sending some of it back out. So I'm going to look at the circuit that takes care of this guy here, what tells it what to do, which is going to be again our Y circuit. So I'm going to take one meter lead, I'm going to put it on common here, and I'm going to go to yellow. And again, I'm looking for voltage if everything's working correctly. So I'm going to look, and I do have voltage there. So that confirms to me that the thermostat is sending power up to the unit in the house. Okay, so I'm going to move on. Normally your units will have what they call a schematic. It's a wiring diagram, a bunch of lines that are almost like a road map for your unit. So I would look at that and I would find out what's the next stop. I know, because I've done this board a lot, that my next stop after here would be my high pressure and my low pressure switch, because those are the next things on that circuit. So I had already started at the yellow wire, so I'm going to go back to common here and I'm going to go to my high pressure switch. And I should see some voltage going into that spot. And I do, which is good. So I want to see it coming out the other side. That would confirm to me that my high pressure switch is closed and still operating. So I'm going to look, and I actually don't have any voltage on there. So what this tells me is that my high pressure switch is open. The voltage is going into it, but it's not coming out the other side. So that would be my problem. So in the field, I would be finding out why this thing popped out. Is it a faulty relay, or is it something that is causing the pressures to get so high in that unit that it's tripping that safety device? Okay, so that would be switch number 2. When the students are complete with that one, they move on to the next one, and they flip the switch again. Okay, this one's very similar to the very first problem we did, whereas everybody has turned off. Okay, so again, I know this blower motor right here is turned on and off by this relay. I know these two components here are turned on and off by this relay. In the field, normally these two things are not going to fail at the same time. Electrical surge, a lightning strike, something like that, yes, but normally not. So again, I'm looking at who tells these two things what to do, which is going to be my thermostat. But again, I don't want to climb down out of that attic. That's a waste of time and money for you guys and your company. So I'm going to go back to where they come into that unit. So I'm going to go from my common up here, and actually let's switch hands so you can actually see what I'm doing. So we're going to go from common up here, and I'm going to go to my yellow circuit right here, because that's what's going to tell what to do. And actually I skipped a step because nobody's working. So I'm going to go to red first. And we want to see if we have power coming from that thermostat. And I don't. So unlike the first problem, we had power here on this wire, which told us that the transformer was sending it down to the unit. But this particular problem, I don't have anything coming into my unit right now. So I'm going to look at who tells my red wire what to do. In the field, you're going to be able to follow a whole wire, and we can kind of follow this one. So this red wire goes up here to my transformer. So my next step would be confirming that my transformer is actually sending some power out. So I'm going to look, and I don't have anything on this side. So again, I'm going to look at who tells this side what to do, which would be the other side. So the low voltage side is told what to do by the high voltage side. So I'm going to take my meter lead. I'm going to go between the L1 wire, the L2 wire, and I'm looking for voltage. This particular one, I do have it. So I have power coming from my disconnect box into the transformer, but it's just not producing the low voltage signal that I want. So my transformer would be faulty. I would replace that out in the field. Okay, so pretty much that's what the students are going to be doing on this electronic troubleshooting, is they're going to be looking for issues, looking for problems. What's causing these things to not work? So on this one, we flipped the switch. This time, I have a compressor and I have an outdoor fan, which is a good sign. But the problem is we're not blowing any air into the house. Okay, so right now there's literally no air coming out of those vents. So I'm not worried about the yellow circuit, because that's what's being told to do what this side. And I'm really not worried about anything up here because these are on. When these are on, that eliminates everything up here. So I'm going to be worried about just this circuit right here, which is going to be my G circuit. So I'm going to go straight to the bottom level right here. This is called the coil. And that's actually what's going to take the 24 volts from the transformer and actually turn my motor on. So by doing this and going across this bottom terminal right here, I was looking for voltage. And when I go across these two, I see voltage on there, which is a good sign. That actually tells me that my thermostat is sending the power down the green circuit all the way to this relay. With power on the coil here, I want to go up to the top. This is my switch up here. This is actually what's going to turn this motor on and on. If I energize this switch right here, this switch up top should close. So when I go across it like this, I would want to see 0, because that means I have a closed switch. And I have 0, which is a good sign. That means that this relay is operating correctly. So all that is going to be in the field would be, this motor would be bad. Now in the field, I would take this a step further. I would check voltage, I would check amp draw, and also the run cap that is associated with this. But because we're working on a limited space board, we don't have any of that, so we're just going to call that a bad indoor blower motor. Once the student completes that, they would log that on their sheet, and they would move on to the next one. Okay, this particular one, we're going to look and see what stops. Now, this one, a lot of students get pretty quickly. Sometimes they don't. You can see that the blower motor is still operating, so that's a good sign. My compressor light's still on. That's actually a good sign. That means that this thing is working correctly. But my outdoor fan is not spinning. Okay, so again, like this other one over here, I'm not going to test this relay, because with my compressor being on, that explains that I have my power on my coil here like I want, and I'm letting the voltage through. So again, this would be just a bad outdoor fan motor. So in the field, I would check the voltage to this, check the amp draw going to this motor, and also the run cap associated with this to make sure that it's getting the power that it needs. Again, student would log that down. They would continue on down the row. Okay, now this one doesn't look like anything's really changed. So the only thing I'm going to do is, normally this relay over here makes a really bad rattling sound. It's called a reversing valve. I disconnected it because it would be like ringing in your ears really bad. So I'm going to check its relay just to make sure that we're working correctly on this one. Okay, now on this particular unit, it's using the O terminal, which means this reversing valve here should be energized when we're in the cool mode, which we are. Okay, so I went to this relay over here on the coil, just like we did with the blower, and I'm looking for voltage. I should have it there, but I don't. So what I'm going to do is I'm going to move from this coil, and I want to see who tells this what to do, which again, I'm going straight over to here. I don't want to climb down out of the roof or off the attic or out of the attic to get to my thermostat, so I'm going to go to right here. Now, I know that this terminal, I actually tricked the students with this particular problem because the wire is hooked up to the O terminal, but I made the color blue. This is to try to help the students differentiate the O and the B terminal on a unit because they both function differently. So on this particular one, I'm going to go from the blue wire to my common. And again, I'm wanting voltage there because I should be getting some voltage from my thermostat, and I don't have any voltage. So that means that I have a broken thermostat wire from the house all the way up to the unit. So this little wire right here from point A to point B somewhere has a break in it. So I would have to try to find where it's broken, where it's disconnected, and fix that problem. Either reconnect it or run a whole new wire. And we just solved number 6, so we're going to move on to number 7, just like the students would. So they're going to flip switch number 7, and we're going to look and see what is not on. So similar to the other one that we had where everything died, again, we have everything off. So I'm going to look at who tells these things what to do. This blower motor, this relay like we already know, these two motors, this contactor. Typically these two relays don't fail like we already talked about. So I want to see, am I getting power to my thermostat? So I'm going to go from the common terminal to the red first, and I want to see some voltage. So I'm going to look at my multimeter, and I have 0. So I'm going to look at who tells this red wire what to do, which you can kind of follow it along, goes to the low side. So I'm going to go to the low side of my transformer between the red and the common, and I'm looking for voltage. I don't have any, so I look at who tells this side what to do, which would be the other side, the high side of that transformer. It takes the high voltage, transforms it down to a low voltage signal. So I'm going to go between L1 and L2, and I don't have any power there. So the last step that I would be doing is I'd be going to the disconnect. So I'm going to move my meter here for a second. This is your disconnect, typically hanging on a wall next to your unit if it's on the side of the house, or it'll be hanging on the unit up on the rooftop. So what you would do is you would pop this thing open, and typically I would pull this screw off down at the bottom, and I'd be looking for some voltage. But what I'm going to do is I'm going to pull my fuse box out here. I'm going to take my meter, I'm going to put it up here so hopefully we can see the voltage. And there's little metal pins in here. Now typically I can go between these two little metal pins here, and if my disconnect is working, I should have 120 volts coming in here. I have about 6, which means I'm not getting any high voltage. So there's two things that are going to cause that. The first thing would be maybe they didn't pay their electric bill, but I'm pretty sure you would figure that out because nothing in their house would be on. Or it could be one of these fuses is blown. Okay, so how we test the fuses is you would take your meter, and on the meter here, and even the meter you guys get in your tool bag has the same function, but it looks like a little sound wave, almost like a little sound bite. And what happens is when you do that, and you take your 2 meter leads, and you put them together, it should make a beeping noise. Okay, that's completing the circuit. So how to test a fuse is you would take the fuse, and you would put one side on this side, one side on this side. That beep confirms that this fuse is okay. Then I would test the other one. One hand here, one hand here. And this one doesn't want to beep at me. Oh, there it goes. Okay, so that fuse is okay. So we now confirmed that it's not the fuses causing that. So it could be they didn't pay their electric bill, or it could be a wire in the back, and we would investigate a little further, pull the wires out, and see and make sure they're not broken or burnt or melted in any way. So I'm going to put those back in there and close that off, and I'm going to put this back up here. So this problem, we have no high voltage, so we would want to find out why, and then we would move on. So the students would log that, and then they would move on to the next one. So again, they would just keep on flipping switches to see what doesn't come on. Now again, this one I know is my reversing valve because it usually makes a really bad screaming noise, but for the video purpose I didn't want that loud screaming noise going on the whole time. So I'm going to go straight to the coil of this relay because this relay is what runs, and we're going to put it back to voltage, otherwise it beeps at you. Okay, so we're going to go back to my coil and I'm looking for voltage. Now this particular problem, I do have voltage on my coil, which confirms my thermostat, the thermostat wire, and even the wire going from there to there, everything's okay. So then I want to go to the top. I want to confirm that my switch closed. So I should see 0 on here. And I do, which is a good sign. So the last step is actually checking this thing to see if it's getting its voltage. So I'd go across these 2 pins right here, and I see voltage, which is a good sign. That means this complete circuit is okay. It's just this little box on here, which is called the reversing valve solenoid, is bad. So we would pull this thing off and replace it. So the students would log that, and they would just continue on and keep flipping switches to see what doesn't come on. Again, everything's on. I know it's my reversing valve because it makes a really screaming noise. So I'm going to go to my coil here. We should have some voltage. I don't have anything. So I'm going to go and I'm looking at who tells that coil what to do, which again we talked about earlier is going to be this blue wire, even though it's connected to the O. So I would go and I want to find out, do I have power coming from my thermostat? So one hand on the blue wire, one hand on the common, and I'm looking for some voltage. This particular one I have voltage, which means my thermostat is sending the power in. So now that is, there's a wire that goes from right here to here, and there's a wire that goes from this side back up to this common. Kind of makes a complete circle or a complete circuit. So what I'm going to do is I'm going to check this blue wire first, and I'm going to go from point A over here to point B over here, and I'm looking for 0 because that would be a good wire. And I have 0, which means that wire is okay. So I have to check the other side. So I'm going to go from this terminal here up to the common on my transformer. I'm looking for 0, and the bad thing is I have voltage on there, which tells me that the wire going from here back up to here is broken, and that's what's preventing this from getting any power. So the students would log that in the field. We would fix that wire. You'd be able to see it. It's either cut, broken, maybe it pulled out of the little connector. Maybe the guy before you didn't crimp that wire down enough and it's pulled out of there. Okay, so the students would log that and they'd move on to the next one. Okay, so this particular problem, my blower's working, which means we're getting air blown into the house, but my outdoor fan and my compressor have gone off, which means I'm not getting any cool air in the house. I'm getting hot air. We're not getting any refrigerant movement. So I'm not worried about anything up here because this guy's on. All I'm worried about is that Y circuit, the one that turns this contactor on. So I'm going to go between point A, point B, and I'm looking for some voltage. And I got 6 volts. Here's the deal in this field. If it's not 24 or more, it's going to be 0. So I'm just going to confirm. I'm going to make sure that both my meter leads were actually on the pieces that I want it to be. Okay, so now I'm reading a complete 0. That's a little bit better. But that tells me that's bad. I don't have any power here. So I have to find out why is the power not here. So I'm going to go back to the beginning of the circuit where it comes in from that thermostat. So one hand is going to go on common here. The other one's going to go to yellow. I want to see voltage. And I do. That's a good sign. So I'm going to continue on that circuit. Again, on the schematic as your road map, you follow that. I know this one goes to my high pressure switch next. So I'm going to check that. I see voltage going in. That's a good sign. I want to see it coming out the other side. So I'm going to look at that. There's voltage coming out the other side. So we had a problem earlier where we didn't have any power coming out of here. This one, it's coming out, which means my high pressure switch is okay. It's closed. So I'm going to move down to the low pressure switch. And I'm going to check that. I see power going in. That's a good sign. But no power coming out the other side. What that means is this low pressure switch is going to be open. So that could be that there's a leak in the system and the pressures are not running high enough, so it kicks it off as a safety device. That could be a wire's disconnected, could be just pulled out of the connector. So you would investigate a little further, find out what's going on with that pressure switch. So the students would log that down and they would keep on moving. Okay, so this one, we have the opposite problem. I'm getting coolness going on because my refrigerant's cycling through the unit, but I'm not getting any cold air blowing in my house. So I'm not worried about my yellow circuit or anything up here because these are on. All I'm worried about is what's not on. So I'm going to go to who tells it what to do, which is the relay. So you're going to go across the bottom pins here. And we're looking for some voltage and I don't have any. So I'm going to look at who tells these two what to do, which would be my green circuit, that thermostat. So I'm going to go from common on my transformer to the green circuit because that's what feeds it. And I'm looking for voltage. Okay, I don't have any. So that tells me I'm already done. It's the green thermostat wire from the house to the actual unit itself. I'm going to flip this switch back to normal real quick. And I'm going to go right back to that green spot just so you can kind of see the difference. So there's my voltage coming into my unit. And now my blower's on because that power is coming in here. But this one, there's no power on there because it's not coming into my unit. Somewhere between this point right here and in the house, this little green wire here, somewhere there's a break in there. So you'd have to find out why. Did somebody cut it? Did a drywall guy shoot a drywall screw through it? Something like that. Students would log that one down and they would move on to the last one on this one. Okay, so the last problem is similar to the other one where we lost everything. So again, my first stop is going to be that red wire. I want to see if I'm actually sending power into that thermostat. So I'm going to go from common to red, looking for voltage. I don't have any. So then I'm going to look at who tells that red wire what to do, which if you trace it up, my low voltage side of my transformer. So I'm going to look at that and see if we have voltage coming out of here. I have 0.8, which is basically 0. So I'm going to look at who tells it what to do, which is this side. So we're going to go over here. And I have 120 volts, which I should. That's what's going to be coming into my disconnect over here. So I'm getting the high voltage into this transformer. It's just not coming back out the other side. So in the field, we would replace this transformer. Students would log that down. They would turn the unit back to off. And they would bring me my paper and I would grade it for them. And that's basically how to do the electronic troubleshooting, or the hopscotching as we call it here at RSI.